Good morning, everyone. Welcome to Designing AI Use Cases for Data Quality Using Advanced Algorithms. My name is Darlene Irby, and I am a speaker and moderator for today's session. I'm the Director for Digital Health at Jhpiego. Before we get started with our presentation, I just have a few reminders that I need to quickly go over. We encourage all of you to ask your questions, but to submit them through the Q&A features. Please turn your microphone on mute and go off camera during the sessions. And we will accept and reject questions in the Q&A feature as they come up, but I will only be able to answer questions during the end of the presentation. We do have a 15-minute break before the next spotlight session, and you as a participant can choose between using digital dashboards to strengthen a media movement, the experience of MTV Staying Alive Foundation, or digital ecosystems applying the 6 Ps in the transition to digital economies. I'd like to take the opportunity to go ahead and start our presentation and introduce our speakers. I'm really excited to have members of my team present today. The first presentation will be led by Matthew Deese. Matthew is a Senior Health Advisor in Digital Health at Jhpiego. Matthew has a master's degree in Business Information Systems and has been working on informatics tools usage and implementation in developing countries for the last 15 years. Matthew's current work encompasses the entire software development lifecycle through strategic systems analysis, software development, customization of existing systems, the structuring of data flows from these systems to periphery systems, and the planning required to maximize the effectiveness of tools and supporting resources in developing environments. Currently at Jhpiego, Matthew assists in the support of various projects related to DHIS2 instances and is extremely involved with data exchanges between various systems. Matthew is also involved in mobile data collection tools, RedCap, ODK, CompCare, Kobo, software development, etc. Our next speaker will be Charles Waka. Charles is the Regional Technical Advisor at Jhpiego based in Nairobi. Charles is an experienced data analyst, currently working as a regional technical advisor for Jhpiego. As an analyst, he works with large data sets pertaining to human subject research and health informatics. He works to make sense out of this data and assist the organization in making strategic decisions. He has extensive knowledge on information systems, and he is highly experienced in DHIS2, CompCare, and ODK-based solutions, RedCap, ArcGIS, et al. Scripting is one of his passions, and the love for Python and R. In his free time, Charles likes reading manga, watching anime, and a fan of Doom Patrol, The Boys, and PS4. Let's start the session. Today, the speakers will share how Jhpiego has utilized Dedupe, Python algorithms, and CSV Dedupe to cluster and identify potential participant duplicates. The speakers will describe how they scale the Python algorithms, the output for a large data set, and the performance. This is important as it allows for entity resolution and fraud detection of programs where participants are remunerated for their presentation. Before we start the presentation, let me give a little bit of background about Jhpiego. At Jhpiego, our mission is saving lives, improving health, and transforming futures for over 50 years. Next slide. At Jhpiego, we have expertise in 38 technical areas: family planning, maternal child health, HIV/AIDS, malaria, workforce, cervical cancer, health system strengthening, and gender. Next slide. We have over almost 3,000 staff worldwide, including 287 nurses and midwives, supporting 126 projects in 35 countries. So we have a very large global footprint. Next slide. This is a list of some of the organizations and foundations that are partners with Jhpiego. Next slide. Digital health at Jhpiego is extensive in terms of the services that we provide, from digital health ecosystems analysis to actually designing client communication systems, data analytics, visualization aggregation, and health information systems design and implementation. At the core of all of the offerings, our intent is always to be scalable, support and create sustainable systems, and use a systems approach, the 3 S's. Next slide. With digital health implementation, there's always a lot of data, but sometimes with all of this data, we always are concerned about data quality. And at Jhpiego, we have a number of information systems that we deal with because we do cover so many countries and so many technical areas. Next slide. I really like this cartoon because it really sort of jokingly points at all of us, looking at data and looking for insights from data using various tools. Next slide. So we hear a lot more these days about analytics, and most organizations start off with descriptive analytics and reporting, focusing on what happened and diagnostic on why it happened. But now, increasingly with the advancement of technology and the ways in which software and other tools can be used to analyze large data sets, increasingly, we're looking at predictive and prescriptive analytics to forecast what will happen and then to also recommend actions based on that forecast. I always like maturity models, and we've shared this a lot organizationally to talk about our journey with advanced analytics and data science. And today we're going to show some examples of how we've moved from descriptive analytics to predictive analytics using 2 global good tools. Next slide. My final slide is just about why it's important for any organization, but highlighting why it was important for Jhpiego. Looking at predictive analytics or data science or advanced analytics wasn't new for our organization, but I think we wanted to be more focused and have a more focused approach. Increasingly, we had more volumes and types of data, and there was more interest in the organization to produce valuable insights. We talk about impact, we talk about, scale, but we need to be able to look at data and provide those insights to support. We also consider ourselves a learning organization, and one of the key advantages of using predictive analytics is to look at learning, and we can understand what happened and why it happened, and then to discover insights for the future. At Jhpiego, we decided to focus on data science and advanced analytics to look at our project focus work. So how to improve the existing projects, how to improve service delivery, how to improve outcomes, and better serve those that we work with globally. Next slide. Next slide. With that, I'm going to turn it over to our first presenter, Matthew Deese. Matthew is going to talk about our experience at Jhpiego with the identification of duplicates with raw data sites using machine learning. Matthew.
Thanks, Darlene. Hi, everyone. So I'm going to be discussing as Donnie stated, I'm going to be discussing the use of Dedupe as a open source tool for the analysis and removal of potential duplicates. So where we first kind of came across and the need and the use for this tool, we have a project based out of South Africa where we had around about 100,000 male circumcisions that were performed since 2017. The issue with this data set was that we were dealing with multiple service providers who were actually performing the circumcisions themselves, and they were located in various locations all around the country, in various different types of environments in terms of connectivity online and offline. And we found that because of the online offline nature of the overall data collection, we were experiencing situations of double capture, identification numbers that were potentially duplicates, minor data changes where we saw certain characters which were swapped around for identification, and in some cases patient duplication actually across regions. So we did some investigation, and we discovered that through the use of a trained CSVDedupe model that we can use to detect potential duplication within our data sets, and can be implemented on other similar programs with client registration data, would be something that we can make use of. We are moving towards a more standard use of this tool, and we're looking at how we can potentially roll it out in other projects as well. So just a bit more detail on the kind of problem that we were looking at. In this case, we have a scenario where we were talking about various differently listed or different rows in the overall data set of people with similar names, John Smith in this case. We looked at how we can, with various little tweaks, John Jacob S could be John Smith. We needed some way of identifying identifying that individual and potentially removing the duplicates from the overall system. And we tackled it with CSVDedupe to provide this kind of solution. So within the South African context, we specifically looked at an analysis based of the patient records with 6 key criteria, looking at facility name, the circumcision date, the name of the individual, the date of birth, and the identification number. And we looked to train a model to cluster the data entries to belong to a single person. So as I stated, we are continuously looking at where we can make use of Dedupe. It's a freely available machine learning app by the Dedupe organization, which I'll cover in the later slides. And the overall use case of CSVDedupe is to identify potential duplicate clients. In our case, with the regular implementation of this app and the overall feedback to our male circumcision providers, we led to a reduction of number of duplicate cases reported from about 4% prior to implementation mid last year to about 1% as of the end of this last quarter. So Dedupe.io is the for-profit company which initially developed the Dedupe algorithm. They have a for-profit web-based interface which can be used for large data sets, but it can be fairly costly, with costing about $9 per 1,000 rows. The benefit of that process is a lot of the training of the machine learning algorithm is taken out of your hands and has been pre-sorted by them. But in this case, we are looking at CSVDedupe, which is the free command line interface, which makes use of the Dedupe Python libraries that Jhpiego has created. Just some details about CSVDedupe, where it's available, and some of these are basically just the very simple steps for the installation. I'm not going to go over this in too much detail. But for how CSVDedupe works, you set up CSVDedupe to access your data via the command line prompt on your laptop or device, and it'll show you various pairs of data items and ask you if they are the same. And from these yes, no, or unsure kind of answers, it then starts building a probability matrix and an overall training file, which can then be used at a later stage to rerun and to continuously build on it. So your overall results get better and better as time goes on and your training is increased. The CSVDedupe then takes that input and classifies everything in the data file, not just those examples, and outputs a new file with duplicates that can be identified and grouped. So the overall anatomy of a CSVDedupe request, and this is from the command line, I'm just going to discuss some of the simpler items here. We have basically we're calling the service itself. We are mentioning the CSV file that we're wanting to work with, which needs to be UTF-8 format in order to function. And then we specify the different field names that we're going to work with. In this case, we were looking at facilities, male circumcision date, the name, date of birth, ID number, age, and then we specify where we're going to put the output file. There are various different other attributes which can be applied. You can also tweak the overall sample size, make use of a stored training file, which can then be built on and continuously improved, and also specify the recall weight, which determines, based on the probabilities that have been assigned, will determine whether or not, if it's 70%, then include, otherwise exclude. So you can play around with those settings as well. So this is an example of one of the CSVDedupe kind of data sets where a person had been, they were assessing amounts of contributions, and you can see in some of these cases, items have been grouped, looking at George Jason Ellsworth and Greg Gianforte items, but ultimately the Dedupe algorithm works as best as the training that you provide to it. So we wanting to train the algorithm based on the data that we have available. Dedupe requires at best, or at the bare minimum, 10 positive and 10 negative matches in order for it to kind of train itself as to how the data needs to appear and be deduplicated. Here we have an example of the overall labeling operation where we've got our John Smith, that's the name, date of birth, gender, first name, and we are asked at each stage on this, do these records refer to the same thing? I'll show a bit more example, a better example on the next slide. But here we have some de-identified data which we made use of in for our male circumcision program, where you can see we are looking here at a patient that is at Hospital Alpha and a patient that's at Hospital Bravo, same name, same ID number, and we're wanting to look at the different dates, different location and different male circumcision dates, and this is a potential case of where information has been shared and something which needs to be looked at. And ultimately what we're wanting to do is create a situation where the information that comes out of the deduplication software allows for further investigation by our in-country team. Looking at the second example, we have same location, different male circumcision dates, and the same ID number. This this points to a potential case of incorrect data capture or double data entry at the location. Again, so something which needs to be investigated. This example, we're looking at two different locations, very different male circumcision dates, but the same ID number and very similar names. We've got Justice Frederick Ngesi versus Frederick Ngesi. So through the training of this process and specifying, are these records referring to the same thing? Yes, no, unsure, or you can go backwards and forwards in the process. It allows us to increase the overall training and therefore the overall accuracy of the duplicates that come out of the system. So after the training, the input file, the overall results came out as follows. We had about 100, I mentioned about 100,000 records. We trained it with, I believe, with 80 positive and 80 negatives in the overall result. We had a total of about 100,000 rows. Overall runtime was under a minute to work through all of that large data set. We found potential duplicates of about 3,250, which then led to an investigation of those duplicates. We then changed the overall business workflow for the payment of the providers to include Dedupe within our dataset results and any payments that do go forward to limit the chances of duplicate payments recurring for the same patient. However, we do still have challenges with the time of data captures, with data capturing and working in online, offline environments with the certain software that we're using for the overall data collection. Thanks. And with that, I'm going to hand over to Charles to discuss time series modeling for aggregate data.
Thank you, Matthew. So, I'm going to talk about time series modeling for aggregate data, specifically health data that is collected on a routine basis from health facilities. Next slide, please. So, a bit of a background is that for most of our work, we do collect routine health aggregate data from service provision sites maybe on a daily basis, on a weekly basis, or in most instances on a monthly basis. So one thing that I believe and that we know is that by utilizing machine learning techniques, you can actually improve the quality of the data that you're currently collecting, and also be able to forecast or predict the expected values for the coming. Next slide, please. So why will you want to do a time series analysis? Basically, we want to see if there are certain factors that influence variables from time to time. You also want to see how useful it is for a given indicator to change over time. For people who have dealt with a lot of data, you actually come to realize that prediction problems, many of them do involve a time component. And then finally, when you do a time series analysis, it will allow you to analyze major patterns and such as seasonality or trends. Next slide. So which model can we use for this? So one of the models that I'm going to introduce is that we're using is the ARIMA model, which stands for Autoregressive Integrated Moving Average. So it's basically a forecasting algorithm which works on the idea that the information that you've collected in the past, basically for a time series, those alone can be used to predict future values. And so the AR stands for autoregression, meaning that the model in itself uses a dependent relationship between observation and some number of lagged observations. So a lagged observation is a period in the past. So it can be a 1 lag, 2 lag, 3 lags, so three times in the past, 4 times in the past. So integrated meaning that we use differencing of the raw observations, subtracting an observation from the previous time step, and then the moving average. So dependency between an observation and a residual error. Next slide, please. So one good thing about the ARIMA model is that it's supported by most statistical software packages, including R, Python, the major ones that you know of, SAS, Stata, and also the SQL applications like Microsoft Postgres. Next slide. So what are the processes that you need to initiate in order for you to utilize an ARIMA model? So the thing that you need to do is, of course, you start with the model identification, such that you use plots and summary statistics for you to identify if there are any trends of seasonality. And then that way, you'll be able to know the amount of differencing if need be, so that you can make the data to be stationary. And then you do a parameter estimation so that you find the best coefficients for the regression model. And then finally, you check your model by using the plots and any statistical tests for the residual errors, so as you can be able to determine if the model in itself is working accurately. So one thing about model building is that the process is usually iterative, and so it has to be repeated until you either get a desired level of fit for an in-sample prediction or an out-of-sample observation. Next slide, please. So what was our process? So we get data from DHIS2. So DHIS2 is where we store the data. We use it for storage and visualization of the routine health data. And then we do have the Python module, the Python scripts for the purposes of sharing written in Jupyter Notebook. And so with the data set with us, we are able to split it into a test and train data set. We plot the model diagnostics, we're able to predict the values, and then finally we check the performance of the model. And then this finally, the program people can be able to review the data, they can be able to do target revision or setting, and also they can be able to utilize the data for data quality check. Next slide. So based on the steps that I've described earlier, so this is what we did for one of our sample projects. So we identify the model based on the visualization. So this is a time series analysis for the number of women who have delivered since 2011 up to around 2020, up to 2021 actually, for the deliveries at a county. So you can see the data in itself may indicate some sort of a trend, but we want to see if we can be able to model this data for us to predict what's going to happen in the future. Next slide. So once we do the model identification, the time series analysis, you have to do what you call an add-fuller test. And this is specifically to test for the stationarity of the data. So stationarity means that the variance of the data is not really influenced. So you cannot say that the data itself is not seasonal. So we just remove seasonality or trends. And so for us to be able to do that, we did what you call a log transformation of the data in itself. And then we did data differencing so that you can remove the trends and seasonality. And we did a check so that we make sure that finally the data in itself for the ARIMA model is stationary. Next slide. So once you've actually made the data to be stationary, the next thing that you need to do is to actually do the parameter estimation. And through this, we do a grid search. So a grid search will allow us to get the best coefficients, which we are going to use and to pass as parameters for the model. Next slide. So once you get the best parameters, then the next thing that you need to do is actually train your model based on the trained data set. And so we use the SariMax model. And in the SariMax model, we pass the training data set values, and then we specify the coefficients that we've gotten from the grid search. Once we specify the models that we get from the grid search, the model is then fit, and then we get a summary of the model results. There are a few things that I've highlighted in red with respect to the summary results, and where it's written, it's pronounced young box. So the young box test, usually it's supposed to be above 0.05, which means that it is non-significant. The reason being that if this is specifically the test for errors, and so therefore, if the young box text is above 0.05, it means that the residual errors are not related, or they are not correlated to each other. And so we usually want this because this is a desirable result in terms of showing the non-significance of the residual errors. Next slide, please. And then once we do that, then we check, we do a diagnostic check of the model to show us how well is the model performing. So the diagnostic check that you can see from the various graphs that are being presented are a couple of things. So in the top right plot, we see what you call the red KDE line. So this is just about the normal distribution. And so you can see that the errors are normally distributed. So it means that our residuals are okay. And then if you look at what you call the QQ plot, which is on the bottom left. So the QQ plot on the bottom left shows that the ordered distribution of the residual errors, which is the blue lines, yeah? They follow a linear trend for the samples taken. Hence, this is a strong indication that our residual errors are normal. So essentially, our model diagnosis just shows us that our residual errors are normal. Next slide. So once we do that, then we try to fit from the model in itself, we now fit the model against the training data, so our in-sample predictions. So the lines that are in blue, these are the actual values. So this is the training data that we have. Then the line that is in red is what the model has predicted in terms of the data set. And so you can see the predicted values and the training values, they follow the same line or the same trend. Next slide. And of course, one thing that you may want, once after you've trained your model, you want to do what we call an out-of-sample predictions, data that the model is not aware of. And so that's where we pass the test, we compare the data that's being predicted against the test value, our out-of-sample predictions. And so the lines that are in, the lines that are in red, those are the test values. These are the actual values that we have from the data set. And the line that is in green, those are the predicted values for out-of-sample predictions. So this means that if you look at the trend of the actual values and the trend of the predicted values, it means our model for out-of-sample predictions follow the same trend pattern. Next slide. So with that said and done, we can be able to see, we can be able to actually forecast the data for the next 12 months. And I just wanted, if you're able to see the top in the slide, we have what you call the mean absolute error and the prediction accuracy. So the current prediction accuracy for the model in itself is 92%. So it means that you can be able, 92% of the time you are able to correctly predict what's going to, what the values are going to be in the next couple of months. And so with this data, with this model, you are now able to predict for the next 1 year, how will the numbers move in terms of the number of women you expect or who are going to deliver at your site, at your county, or at your country on a month-by-month basis. Next slide. So what are the benefits for this? Of course, you're able to identify patterns. You're able to see. So the good thing about this is when you talk about pattern identification is that you're able to see the type of data that you're currently collecting. Is it seasonal data, or is it a trend data, or is it a random data? And then it gives an opportunity to clean data, so which means that if something occurs out of the extraordinary, you have a sudden jump in terms of the number of women who have delivered as opposed to what the model has predicted, then you're able to try to see what has happened with respect to the current data that you collected. Then you can predict the future with it. And then always you can, the good thing about this, you can also get good output with less variables. Like for the time series analysis, we have the value and the time in which it occurred. Next slide. So what are the limitations? So definitely, one thing about data science and any type of modeling is that for you to be able to utilize it, you need to really understand how the model works so that you can actually be able to make sense of its output. And then, of course, for the ARIMA model that I've displayed, it was generated through Python. And so for you to be able to utilize it, you at least require at least an intermediate understanding of Python, including Python functions and Python classes. So yeah, so thank you.
Hi, everyone. Thank you very much. I know we ran over a little bit and we started a little bit late, and I wanted to open it up for any questions.
Darlene, I see that there are 2 questions in the Q&A section relating to the Dedupe side of things. So I'll just take those.
Okay.
Are there any plans to use Dedupe in other ways beyond VMMC? Yes, we are hoping to make use of it. The main use case we found for it has been within VMMC at the moment. That's where the initial need was, but it is flexible enough for us to use it in various other cases, specifically looking at anything relating to overall patient counts or beneficiaries that are being given grants, like that kind of thing. The second question from Gillian, were these patient data being captured in a broader information system? Yes, we made use of, within the South African context, we were making use of Demaji's Comcare for the data collection, which operates online and offline. And your second part of your question is, would it be possible to run the Dedupe functionality within the software for data collection without exporting and analyzing? Ideally, that would be great. Part of the challenge we've had has been the collectors of the information have been out in the field and may not be updating information on a day-to-day basis. And when the information isn't synchronized, we've had some challenges in getting the overall or elements of the duplications down, because there have been too many stretches of days where information hasn't been put up. So that would be the ideal. Just unfortunately, with the online offline environment, that's not something that we're able to do at this time.
We have time for a couple other questions. Are there any others? Well, I'd like to first thank the members of my team, Matthew and Charles, for their great presentation. And I'd like to thank the audience for participating and listening to Jhpiego's experience with using advanced analytics to improve data quality and analysis and prediction. And we thank you very much.